Hello everybody. This is the second video from the series devoted to the study of the algorithm of automatic biostatistical analysis, which will allow you to quickly analyze any amount of data with automatic selection of statistical criteria, the presentation of descriptive statistics and graphs. First of all, we need to upload our database, which we placed in the repositories of our project. To do this, use the Load Workbook function from the Excel Connect library. Next, read Worksheet to download this from a specific sheet. In our case, this is Sheet 1. Then we need to download the Word file template, which will be used to generate our document. It can be just an empty docs file, or you can already add some information to it, including headers and footers from the very beginning. Check if the database is loaded. Now that the database is loaded, we need to load the names of all the variables that the database creator specified. We use the colnames function, which is included in R by default. It returns the names of all columns in our database. There is one feature. The colnames function converts spaces to periods. For us, for the correct display of variable names and subsequent ones on graphs and tables, it is necessary to preserve spaces between words. To do this, we use the gsub function, which converts all dots back to spaces. In this case, of course, all real points will also be converted to spaces. To do this, we ask the user not to use periods in variable names, which is easier to execute than not to use spaces. Next, add the first level heading for our table of contents, and then the table of contents. It will be automatically generated from all the headers. The title level will be taken into account. We set the maximum number of sublevels and go to the next page. We initialize the creation of variables in which our data will be written. Variable v, which will divide the output into sections, if we need it. In the previously created variables var1 and var2, we write the column numbers of the analyzed database, which we want to include in the analysis. In the future, we will also use the var subgroup variable, which will allow us to divide the analyzed groups into subgroups, if necessary. Cox regression is not touching. Now go to the code. We open a cycle by the number of elements in the var sheet 1. For each of them we create a separate level 1 heading with the section number. Next, open a cycle by the number of elements in the var1x vector, and in it a cycle by the number of elements var2x. Thus, inside the first part, we can now map each element of the var1 vector to each element of the var2 vector of sheet x, that is, for a specific section. Create two variables. Nanosecond is a local variable that will return the element of the vector var1x corresponding to the iteration, and var2x corresponding to its iteration. This is necessary in order to get the column numbers of the database that will be analyzed, as well as to get the names of the analyzed variables. df is a local variable in which a temporary database will be written, containing only the variables involved in the analysis. This is done for the convenience of working with data. Next, create a second level heading, which will first include a link to the column heading with the value of the var1x variable, which is recorded in the var_names_clear variable, and a heading with the value of the var3x variable, which is also recorded in the var_names_clear variable. The paste function is the base and and allows you to combine text. Adding sep at the end of the function allows you to specify a separator between the elements of the text to be joined, since by default it is represented by a space. After closing the loops, we use the writeDoc function to generate the file. Thus, the results of our algorithm were recorded in the results.docs file. Run the code. Open the file. The table of contents was generated. It is clickable. The names of the variables that we wanted to include in the analysis in each section are displayed correctly. In the next video, we will continue the analysis of the algorithm. If you like this video, like and subscribe. Thank you for watching.